we now come on to a weighted network. So all these activities now have a time attached to them, a duration, and in this example I've put hours, but it could be days, it could be weeks, or in some projects it could even be years, especially if you're building a new changing room in Hagley Park. Now, the activity network has been drawn from this precedence table, except you'll notice the events this time are drawn differently because each one's got two boxes, and those boxes actually mean something. They give us what are called the early event time and the late event time. The early event time is the earliest time of the next activities. So say for example we put a number 3 there. This means C cannot start until time 3, or today's day is day 3. Or from the end of day 3, depending on how you've done it. The bottom numbers represent late times, and it's really important you realise that this box relates to the activities following on from it, so it relates to C. This box relates to the activities leading into it. So the late time is the latest all the activities going into it must be finished by. And if that doesn't happen, you have a delay in the overall time. And this overall time here is called the critical time. That's the shortest time the whole project could be completed. So if you draw lots of different paths through the weighted network, you could say you do A, then C, then F. Now you can't do C until A has been completed, you can't do F until C has been completed. So that would take A, C, F would take 12 hours in this case. But is there a longer path? So we could do A, C, down the dummy, G. So A, C, G would take 5, 11, 19 hours. Let's see if I can get a longer one. 2, 9, 17, 2, 8, 16, 2, 8, 9, 2, 5, 11. So there's no way of getting a longer path than ACG, so that's what's called a critical path. There are easy ways to find it because it's quite a simple example, which we'll come on to later. So the first thing we need to do when filling in this chart is what's called the forward scan. And you notice this chart's very similar to Dijkstra's, except it's not. You know, Dijkstra's got the 3 boxes at the top, so it's different, it's a totally different question. But forward scan's very similar to Dijkstra's. So we start off on the start of the project with a 0, because you haven't done anything yet. And then you need to, when you've got a choice, you need to look at the activities going into the events, and when you've got a choice, you'll pick the biggest number of the 2. So here, there's only 1 arrow going into here, so this is 0 plus 2 is 2. This one, on the other hand, we've got 2 arrows going into this event. So you've got 2 plus 0, 0. Dummies have a weight of 0. 2 plus 0 is 2, 0 plus 5 is 5. So because 5 is the bigger of those choices, put the bigger number in the forward scan. So remember, forward scan, forward on the top numbers, you pick the biggest number when you have a choice. And although I said the biggest number of all the activities we're working forwards, what I mean by working forwards is moving through the chart, but the activity can go backwards, but it's just the way it's been drawn. Okay, so this one, we have got no choice. There's only one activity lead into this event, so 5 plus 6 is 11. This has 2, so you've got 11 plus 0 is 11 versus 2 plus 7 is 9. So 11 is the winner. Now, this is one where a lot of students will make a mistake and they'll put 9 because they'll forget about the dummy. The dummy matters. 11 plus 0 is 11, 2 plus 7 is 9, 11 is the winner. Only one choice into here, 2 plus 3 is 5, and then we've got 3 events going into the last event, which will be the sync node. So you've got 12, V19, V11, 19 is the winner, which was our longest path, the critical path. So this is the critical time. The critical time is the shortest time the activity could be completed with an unlimited number of workers. Okay, to fill in the bottom numbers, you do what's called the backward scan. With a backward scan, you go against the arrows, working backwards to fill in the bottom numbers, and then where you have a choice, you'd pick the smaller of the one of the two. So here, for example, I might have, I don't know what this number's going to be. The bottom number's always got to be the same or bigger than the top. If you've got a number here that's smaller than the top, you've done something badly wrong. So say this was 14, you'd have 14 take 7 is 7. Say this is 10, 10 take, look at this, 11, 11 take 3 is 8. You pick the smaller one of the two. But there is an easier way of doing it. And the easier way of doing it is to use your critical path. So in order to find the critical path, you would work backwards, looking for where there's no gaps in your subtraction. So what I mean by that is 19 take 6 is 13, not 5. 19 take 8 is 11, bingo. 19 take 1 is 18, not 11. So this must be part of my critical path. 11 take 7 is 4, not 2. 11 take 0 is 11. 11 take 6 is 5, no gap in the subtraction. 5 take 5 is 0, no gap in the subtraction. So this would be your critical path. And the reason why it's useful to do that is anywhere along the critical path, you'll have the same number in top and bottom. And where you've got the same number top and bottom, those are called critical events. So critical time, critical path, critical events. And anywhere, all the activities along your critical path are called critical activities. So A, C and G are critical activities. A, C, G is the critical path. There could be more critical activities than that, but that's your critical path. And same number top and bottom is a critical event. Now, it doesn't necessarily mean any activity joining up to critical events is itself critical. F here is not a critical activity. I'll explain why later. But it joins up to critical events. The reason is because the critical path, although it passes through those events, so they're critical events, you can have other activities join them up, as in this case F does. But now you can see why that's a useful thing to do. So you do the forward scan, work out your critical path by going backwards, no gaps in your subtractions, then fill in all the bottom numbers along that critical path, top and bottom are the same, and that's knocked out most of the numbers on your backward scan, because backward scan is harder than the forward scan, so it'll save you a lot of time. So now doing the backward scan, we can see we'd have 19 take away. You do bottom numbers against the arrow, subtracting. 19 take 6 is 13. Backwards, backwards. Don't miss this one. Got this one as well. Very, very easy to make that mistake. It's got 13 take 3 is 10. 11 take 7 is 4. 5 take 0 is 5. So 4 is the winner. You put 4 in the box. You pick the bigger number when there's a choice in the forward scan, small number when there's a choice in the backward scan. So that diagram's now actually complete. So, so this top number is the early time, the earliest start time in the activities. The bottom time is the late event time, the latest those activities can finish. So now we can come on to something called float. So activity 6 depends on the top number where it begins to the bottom number where it ends. This number relates to this activity. This number relates to this activity. These two numbers relate to C. This is its early time, so it can only start after 5. It must end by 11. So if you say in terms of day, I don't say this, but say in terms of days. So from 5 to 11 gives you 6 days to play around with. C actually takes 6 days, which is why it's a critical activity, because you've got no spare time, no time to play around with it. And that time to play around with is called float. So C has a float of 0. It's a critical activity. when we come on to scheduling at the end of this chapter, this activity you'd give to your most tried and trusted worker. So you'd actually give them these 3 activities. So they're going to not mess around, they're going to get the job done, no delays, no messing, job done, brilliant. Let's do another one now. Let's do, say, E. So E, its early time is 2, its late time is 13. So from 2 to 13, you've got 11 days to play around with, but it only takes 3 days. So this will give you a float of 8. Now the calculation to show in the working for the float on E, you always go bottom, take middle, take top. So the float on E, the way you'd write it is 13, bottom, take middle, 3, take top, 2, 8. So you do the late time, take away the activity time, take away the early time to work out float. If the float equals 0, it's a critical activity. So what this means is E has got 8 days to play around with. So you could start on day 2, finish on day 5, you've got 8 days where you're not bothered, or you could even start on day 10, finish on day 13, all good. You couldn't though start on day 11, because 11 plus 3 is 14, you're not going to finish on time. So provided you start anywhere between 2 and 10, all good, you're going to finish by 13, which is what you must do in order that there's no delay to the whole project. So just to recap, top number, early time, that's the earliest this one could start. Bottom number, late time, that's the latest activities going into it must end by. Forward scan, fill in the top numbers. When you've got a choice of arrows going in, you pick the biggest number, then do the critical path, starting from the critical time, working backwards, no gaps and no subtractions, then mop up any remaining numbers by doing the back scan, subtracting on the bottom numbers. If you've got a choice like we had here, you pick the smaller number. The float is the spare time in an event. So because this goes from day 2 to day 13, 11 days, only takes 3, you've got 8 days to play around with, that's called your float. So let's have a go at filling in. I think this has come from an old exam question from start to finish. So I'm going to fill in the early times, find the critical path, list the critical activities, fill in the late times, what's the float on D? A typical exam question, you're probably talking about 2, 3, 4, 5, 6, 7, 8, 9 marks, so quite a big marker in the exam. So let's have that filling in then. So we start with the forward scan, so 0, the source node. So 1 arrow into here, so that must be 8. 2 arrows, 1 arrow into here, so that must be 9. I've actually got 3 arrows into this one. So I've got 8 plus 7, 15. 0 plus 9 is 9. 9 plus 11 is 20. 20 is the winner, as it's the biggest of all the choices. Here, 9 plus 8 is 17. 20 plus 0 is 20, so 20 is the winner. 20 plus 2 is 22. 8 plus 5 is 13. So now we've got 22 plus 0 is 22. Versus 13 plus 3 is 16, 22 traits, is it? 22 plus 9 is 31, 20 plus 11 is 31. Now that's interesting because we've got 2 ways of getting there to 31, which means we've probably got more than one critical path. 31 plus 7 is 38, 22 plus 6 is 28, 38 wins. That's the critical time. That's the shortest the project can be completed by, where it's hours, days, weeks, months, whatever. Okay, let's find the critical path. So 38 take 7 is 31, 31 take 11 is 20, but I can now need to remember that I also could do 31 take 9 is 22, so I'll come back to that later. So 20 take 8 isn't 9, careful, it's actually 20 take 20 is 0, 20 take 9, 11 is 9, 9 take 9 is 0. So one critical path would be C, E, dummy, don't bother putting dummy in or doing anything there, K, M. But, now one clue in the exam is if it says paths rather than path, you know there'll be more than one. So here 31 take 9 is 22, 22, take 2 is 20, and then you can follow the same path back to the source node. So another critical path would be C, E, H, J, M. Critical activities, those are any activities that are along the critical path. So you normally write them in alphabetical order, but it doesn't matter if you don't. So we've got C, E, K, so H, I, J, so H, J, K, M. So just make sure you tick them off. C, E, K, M, C, E, H, J, M. You haven't missed anything. Fill in the late times. Now, filling in the late times, we can get rid of most of them by anywhere along the critical path or paths, same number top and bottom. So I've only got these top ones to mop up. So only one arrow back into this one, so 38 take 6 is 32. Only one arrow back into this one going backwards, 32 take 3 is 29. But I've got 2 arrows back into this one. So I've got 29 take 5 is 24, or 20 take 7 is 13. 13 is much smaller. Pick the smaller one. Biggest on the forward, smallest on the back. What is the float on D, E and F? Well, firstly check out this, because E is critical, so E, float on E equals 0, because it's a critical activity, so I need to do any work with that. Let's do the float on D. Let's find it then. Where is D? Here. Awkward to do, but go from top, middle, bottom. That's the early time, that's the late time. So you've got 12 hours to play around with. Take 7, so the float's going to be 5. But showing the work in, late time, take event time, take early time, which is 5. Let's do the float on, what's the other one? F. Where is F? So F has the same early time, but a different late time. So this one you go 29, take 5, take 8, bottom, take middle, take top, late, take activity time, take early time. So 13, so that's 16, so you've got a lot to play around with there. Okay, one more, exactly the same, just a bit of extra practice. 0, 10, 14, choice, 21 v 19, 21 wins. Choice, 33 versus 29, 33 wins. No choice into there, 29. No choice there, 34. Oh no, there is a choice. 34 v 39, 39 wins. 43 v 45, 45 wins. 54, 54, 51. So you can have more than one critical path. So critical path time. So 54 take 9 is 45, 45 take 16 is 29, 29 take 8 is 21, 21 take 11 is 10, 10 take 10 is 0. But I also could have done 54 take 21 is 33, 33 take 12 is 21, and then you've got the same critical path. So the critical paths are going to be A, C, G, I, M, or A, C, H, K. So the critical activities, A, C, G, I, M, A, C, H, K. Except I haven't done it in alphabetical order, but that doesn't really matter. Fill in the late times. Oh, look how many you can mop up now before we even do the back scan. So it saves so much time doing the critical path first. Back scan, 54 take 12 is 42. You have got, this one's more difficult there because you've got 1, 2, choice of 3. 42 take 20 is 22. 33 take 15 is 18. 21 take 5 is 16. So with all those, 16 is the smallest. What's the float on D, E, F? D, E, F. Well, none of them are critical, which is a pain. So float on D, float on E, float on F. So where's D? Do you see it? Late, take event time, take early time. 21, take 5, take 14, equals 2. Float of 2. Float on E, 33, take 15, take 14. So what's that take away? 19, 29, so that's float to 4. And you've got 14 to 33, so that's what, 19. Takes 15, it's got 4 spare. Float on F, same starting point again. But we've got 42, take 20, take 14, so take away 34, so it's going to be 8. Got a bit more spare to play around with on that one. Okay, now if you have a go at exercises 8C, 8D and 8E. I think it splits it up, so 8C is the forward scan, 8D is the back scan, and 8E is the float, if I remember rightly.